So, oh,
Brianna Williams, please come to the main office. Brianna Williams, please come to the main office.
let me change this text color really quick. Okay, there we go. Okay, so with this flip chart, this is looking for Pythagoras section 1.2, and what we're looking at this one, these are the three things that we want to do. We want to review the properties of quadrilaterals. We want to connect those properties of figures to coordinate representation. So basically, what we're going to do is we're going to draw shapes on a coordinate grid, draw shapes on a coordinate plane, and then determine whether they possess the properties of quadrilaterals. Okay, so we may draw what we think is a square on the coordinate grid, but we want to check the properties of quadrilaterals to make sure that it really possesses those qualities, those properties. All right, so some vocabulary that we need to look at. Black text here. Okay, so vertices, corners of shapes. So corners. Origin, it's 0, 0. It's where the x and y axes meet. Or I guess maybe cross would be a better word. Okay, it's where they cross. And then a right triangle is one that has a 90 degree angle.
Hallie Polk, if you're still in the building, please come to the main office. Hallie Polk, please come to the main office.
Okay, so basically what we're still going to be looking at is we're going to be looking at, if you remember in 1.1 we started talking about the city of Euclid, and they want to design a park, and they're going to give different geometric shapes and different constraints. So a constraint just means restrictions or limitations or requirements. So they want to design a park, but it has to have certain requirements that it needs to meet. And so Descartes Park is one of these parks that they want to put into the city, but it has to have vertices, corners at 1, 1 and 4, 2. So it has to have corners at these 2 points right here. Okay? So take about a minute or so and see if you can figure out how to draw a right triangle with these 2 points as 2 of the corners, and then you just have to figure out a third corner that would work. Now, it doesn't have to be one of the existing locations here. It might end up being that way, but if you can find a location that would work that's not one of those, that's fine too. So just take about a minute and see if you can figure out a third location that would make that triangle, a right triangle. All right, so hopefully you're in pause now, and most people found either this triangle right here, or they were able to find this triangle right here. So if you notice, this would be the right angle for that triangle, and this would be the right angle for this triangle. Now, some other people found that if you draw this right here, now this becomes a right angle, and similarly, if you were to draw this triangle, this would also be a right angle. So there's more than just these two. We only want you to find one, but just to show you that there is more than one option, these are some other options that you could have, and these both could be flipped from down here. You could rotate them so that they rotate their tips up here, and so then they would be drawn up in this direction like this, and their angles would be right here. All right, so properties of polygons. This is something that's going to be really important because when we draw our shapes, we want to make sure that the shapes that we draw really are squares and really are rectangles, non-square rectangles, and really are parallelograms. All right, so if we're talking about a square, okay, a square has 4 congruent sides and 4 90-degree angles. Okay? A A non-square rectangle, opposite sides are parallel and congruent, and 4 90-degree angles. Okay, so the opposite sides have to be congruent, and you have to have 4 90-degree angles. So 1, 2, 3, 4. And this little square here, remember, just means that that's a right angle, a 90-degree angle. And then the parallelogram has opposite sides parallel and congruent. Okay? Now the other thing with parallelogram is that your opposite angles are also going to be congruent. So like this angle here would be equal to this angle, and this angle would be equal to this angle. So let's see if we can. There we go. All right, so go ahead and pause if you need to write this down, or if you need to write it down, maybe you'll remember it on your own. All right, and then this is just showing how quadrilaterals are related. So quadrilaterals are just, remember, four-sided figures. Okay, that's it. So all of these things in here are four-sided figures: trapezoids, parallelograms, rectangles, rhombuses, and squares. Now, all trapezoids are quadrilaterals, but not all trapezoids are parallelograms. And in the same way, all parallelograms are trapezoids, but not all parallelograms are rectangles and rhombuses. In the same way, all rectangles and rhombuses are parallelograms, but not all of them are squares. And a square has properties of all of these things. So it's the smallest group. All right, so suppose the park is to be a square. What could be the coordinates of the other two vertices? Now remember, when you draw your park, these have to be two of your vertices, okay? So pause for a couple of minutes and see if you can come up with at least come up with at least one square that could happen using these two as your vertices. Now you may have to think a little bit creatively, you may have to think outside the box, but go ahead and pause for as long as you need to see if you come up with at least one square that would work using these 2 points as corners. Okay, so this would not work. All right, so hopefully you were able to find one. Now this first one I think is kind of screwy. This is the first one I would have thought of. Okay, so there's one square. And if you think about this, you could take this square and just reverse it so that it comes down this way, and that's the other square that they were thinking of. Now the third one is a little bit tricky, and it looks like this. So they use non-consecutive vertices as these 2 points here. So if I take these two off, maybe it'll be a little bit easier for you to see. So one of the strategies that we talked about for finding the square is, if you find the slope between these 2 points, you would go up one. If you think about the driving directions that we talked about in 1.1, if you go up 1 and to the right 3, okay, your slope for your other 2 lines is going to have to be the opposite of that. So what we would do is we would switch these 2 numbers around, and we're still going to go up, but now instead of going up 3 and right 3, we're going to go up 3, and instead of going right, we're going to go left 1. So now these are our new driving instructions, and these are going to be our 2 new starting points. So to get from here to the next 2 points, what we're going to do is up 3 and left 1. So up 3 and left 1. And then same thing from this point, up 3 and left 1. And so then that's where we get these, that's where our square comes from. Now if you take a piece of paper and you put the corner on this corner right here, it should match up if it's a 90-degree angle. And if you take a ruler and you measure all 4 of these sides, they should all be the same length. So that's what we're talking about with the goal when we want to connect the properties with the coordinate shapes. We just want to make sure that the figure that we think we've drawn as a square really is a square. All right, so for the next one, a non-square rectangle. So remember, a non-square rectangle, if we flip back here really quick, a non-square rectangle has opposite sides parallel and congruent with 4 90-degree angles. Okay, so pause for as long as you need, see if you can come up with 3 non-square rectangles using these 2 points as your vertices. Okay, so hopefully you were able to find at least one of those rectangles, and there's lots. The rectangles, squares, there's only 3 options for, at least for this one, but for the rectangles, there's almost kind of a limitless amount. So one of the most popular ones that people found would have been this rectangle right here. And it could have been cut off right here and gone across like this. Actually, that was our square that we found. So it's kind of like they just took that square and they doubled what we had earlier. And again, if you think about taking this one and just flipping it to the other side here, you could take this and reflect it on its base right here so that it was reflected up on the other side. And we would just, the only reason it's not shown here is because we've run out of space at the top of the grid. Another rectangle that you might have found was really common, the one where you had the 2 triangles from the other problem. Let me get this one out of the way and I'll change the color of this. There we go. So this is kind of like those 2 triangles that we had earlier, just put together. That was a really common one that people found. And then the third one, which I think is, my brain doesn't work like this. I never would have found this one. But there are lots of them that are like this, and there are more than just those 3 that we found. Okay, so then the next one would be the parallelogram. And if you think about what we said about a parallelogram, opposite sides are parallel and congruent, and opposite angles are parallel and congruent. Okay? Now they don't necessarily need to have a 90-degree angle, but they could have 90-degree angles. So again, using these 2 as your vertices, see if you can come up with at least one parallelogram on the grid. Okay, so parallelograms, and usually your teachers show you that something like this is what a parallelogram looks like. So this is kind of the shape that we're looking for, and we saw that before when we were talking about the properties of parallelograms. So, all right, so the first one, there's the first parallelogram. And then again, you could think about taking this and flipping it up so that it would go like this up here instead of going down like that. The next one would be something like this. And again, this could also be flipped so that instead of going this direction, your parallelogram is coming this direction. And then the third one here, maybe I'll take these other 2 off so you can see that a little bit better. Again, your opposite sides are parallel, these sides are parallel, and these opposite angles are congruent. All right, so no homework for this section, but this section is really important because what we're leading into is being able to draw squares on a coordinate grid, and not always nice squares. So the next flip chart that I'm going to post is going to be kind of an extension of 1.2 where we practice a little bit more finding squares in the coordinate plane.